I'm going to start out by saying thank you for the invitation to be here today. I'm truly honored to be among this list of superstars in the field. My name is Lorna Quandt. I'm an assistant professor at Gallaudet University in Washington, D.C. Gallaudet is well known for being the primary institution serving deaf and hard of hearing undergraduates, and you'll see that reflected in the work I share today. Somewhat similar to Emily, my background is really in action perception. So I've done a lot of work in the cognitive neuroscience of how we understand and perceive and make sense of other people's actions. And as you'll see in this talk today, my work has taken a turn to emerging technologies in a way that I never would have expected, but is allowing me to explore some really interesting questions in this field. So I'll be taking on challenge C today, probably not answering any of the questions in this challenge, but more like highlighting their importance. And I'll do that by talking to you all about embodied sign language learning in virtual reality, where I use EEG as an implicit measure of learning. So we'll start by talking about learning as a social process. So far today, we've talked about a lot of different types of social interactions, and I will make a case for learning as a particularly important type of social interaction. And then I'll explain a little bit of how that relates to the work that has been going on in my lab for the past few years, and how we can evaluate those types of social learning interactions. So we have new exciting tools, emerging technology that can allow us to learn in different ways. So thus far today, I think there's been a lot of discussion of humanoid robots or other types of physical technology that we can interact with. My work and my interest has really focused on something that's not as physical, but instead is virtual. So I'm very interested in social robots, but I don't have particular research experience with them. Instead, what we focus on in my lab is virtual learning in virtual environment spaces. So back to the learning. I think that the best learning is social. And I think that much research would support that statement, that learning when it occurs in a social situation, either with a teacher or with peers, is a richer and more likely to succeed form of learning than most other alternatives. You can read from a book, but you can also learn in a classroom from real people. So virtual reality, which I'll talk about VR today, but we could also talk about mixed reality or augmented reality. Virtual reality, when you put on a headset and you enter an immersive three-dimensional space, allows you to engage in a few different types of learning. Of particular interest for me is learning from a person in VR. What can that look like, and how do we know if it's working? What does it mean for that to work? So an important point of learning in a virtual space is, if it's social learning, who are we learning from, or who are we learning with? So imagine that you were doing a job training or trying to learn a new skill in virtual reality. You might be interacting with a sort of teacher or a guide, and they look a certain way in virtual reality. How does that matter? How do we figure out what they should look like or what impact that has? Up until a few years ago, I might expect that learning from a virtual human would look something like the upper left, where we have sort of a blocky, chunky, low-res person. Animation and the rendering have increased the capacity of building virtual humans to levels that we would have thought were impossible not long ago. So the most recent release that I'm aware of that really made my jaw drop is these meta-humans from Unreal on the lower right. And this is a tool that anyone can use to create virtual humans, and they can be placed into virtual spaces. So very soon we're going to be interacting, or we'll have the capability to interact with virtual humans who are not real, who look real. So what will that be like, and how will that impact what we can do in virtual spaces? Also, if we can design a teacher or design a character in VR, how should we design them? What should they look like? These questions I come at from a sort of social neuroscience perspective, but you could just as easily come from a number of different backgrounds. Animation, design, user experience. As we all know, this is truly interdisciplinary and requires input from all of these fields. So what makes a good virtual social interaction? If you're interacting with people in VR, how do we know if that's going the way that it should? We can turn to the same types of fields that we would ask about real life, non-virtual interactions: social neuroscience, social psychology, cognitive neuroscience, human dynamics. And I think that something that has stood out to me in looking at virtual interactions is we have to be cognizant of what is the goal of that interaction. So if I go get my Oculus Quest headset and put it on, there are a number of different social things that I can do in my virtual reality space. I might go virtually hang out with people to watch a concert, and those could be real people or they could be just avatars. So I might be looking for entertainment. There's also been a rise in like virtual co-working spaces. So if we're all home because of COVID, maybe Ava and I could put on our headsets and work in a virtual coffee shop together, and it would feel maybe like we were really together. Or you could look for social connection in VR, just the pure, feeling of connecting with a person. So there are many different types of interactions, but what about learning something from another person in VR? We could learn from a teacher, we could learn from someone who's training us to learn a new skill. Maybe we're in a virtual classroom with other students. But I think it's important to remember for any analysis of these new types of virtual interactions that different things matter depending on what the goal is for that interaction. So I'm particularly interested in how we teach a specific skill in virtual reality. For the past few years, my lab has been working on developing an American Sign Language teaching tool in VR, developing and testing that. And here I'll talk about American Sign Language because we're in the US, but this could be applied to any sign language from across the globe. What motivates the idea of taking on this research? Why would we want to? Why now? So I think that there's some evidence, and it seems clear to me as a person who has been learning ASL, that learning from a person is much more successful and better than learning ASL from books or videos. All sign languages are three-dimensional. They're, fully fledged languages that are expressed on the hand, body, and facial expressions. They require, fluid movements through time. You can look at books to learn ASL, but it's not going to be the same as learning from a person, whether that's virtually or in person. Like learning to dance, you would not want to learn to dance by reading a book. So we felt a desire to make it happen. Let's do this in VR. At the same time, we realized that the technology for making fluent avatars who can produce and communicate in sign language has advanced to the point that it's not too hard to make high quality fluent avatars who we make them using motion capture, but there are a few different ways. But we can make virtual humans who sign and it looks pretty good. And that was not true until recently. And finally, I'm interested in this question because it really capitalizes on the idea of embodied learning. So when we're learning to sign, whether in person or in a virtual space, how are the embodied learning mechanisms that we know are present in the human brain contributing to that process? So I'll show you what our system looks like. It is called Signing Avatars and Immersive Learning, or SAIL for short. And like I mentioned, we're combining here embodied learning, virtual reality, and these high quality motion capture signing avatars. So I can show you a quick run through of what this looks like. A user puts on a head mounted display. And here you see the immersive virtual space is being mirrored on an outside monitor. But for the user, it really feels like they're there and interacting with this character. So this is our teacher avatar, and she teaches basic American Sign Language to the user in 3 dimensions. So you can see they're having a somewhat social, somewhat interactive exchange in this virtual space. There's also room for improvement, but we won't go into that too much right now. But we've shown that this is possible and we can create this sort of teaching environment where a teacher guides a user. But we wanted to put a lot of thought into how to make the teacher, because as you've already heard from the other talks today, and we know from the research, it matters. Does the teacher look like someone who you would want to learn from? Do they look real or too almost real and they fall into the uncanny valley? Are they too robotic? So we discussed, all sorts of different choices along various spectra. And we wanted to create a teacher avatar who would be producing clear signs, expressive in hands and face the way that we needed her to be, and who would also have the sort of more intangible characteristics of seeming warm and competent. So we've done some user ratings, large scale online user ratings, to show that people do generally find her to fit these characteristics. But this is a version from right before the pandemic, so still improving. But I wanted to point this out because we know that in an online virtual learning environment where you're interacting with a person, a lot of a person's experience is going to rely on how does your teacher avatar look, how do they move, and how do they communicate. And this is a good time for a caveat with this work. If you want to teach someone a new skill, such as learning American Sign Language, it is probably best to do that in person with face-to-face interactions with people who are fluent in the language. So we don't want to argue that what we're doing is better than real life, but rather that it can inhabit a in-between compared to those real life learning interactions in comparison to something like teaching yourself from a YouTube video. Of course, there are VR learning experiences that can't be replicated in real life, or are very, very hard to replicate. So there are, things where you can learn how to do mechanical and repairs on the International Space Station because you're in virtual reality. But for us, we're just trying to replicate the good parts of a real in-person experience. So on to our challenge. We have an interaction with a virtual human, and we can put people into this experience and they can learn some new skills, they can learn some new vocabulary. How do we know if it's working? So I'm going to walk you through some thoughts about this in general, and also what it looks like for the project that I've described here. I think everyone who's watching this already has the idea that if we want to evaluate something like social learning, we can do that in part using behavioral measures. We can ask people for, how well they recall things, or give them a test, or, any number of sort of traditional learning outcomes. And we can combine that as well with neural responses and also psychophysiological responses. The goal of combining these two types of measures would be to provide a more complete picture about what responses are there during a social learning experience like this. So for something like teaching sign language, which is a physical, social, and embodied learning task, we're using our hands, bodies, and the physical space around us to complete the learning task. It is inherently physical. So for this particular instance, we're looking at this through the framework of motor resonance. So how much does the viewer embody the movements of the actor, and how does that change based on whether you are engaging with the teacher in a 3D immersive space compared to perhaps watching a video of the teacher? So looking both at the effect of interacting with the teacher and the immersive nature of that interaction, where you can feel the 3 dimensions around you. And this is motivated not just by the idea that motor resonance might be relevant, but a lot of research, which I'm sure my colleagues are familiar with, and hopefully the audience knows some of these ideas as well. We know that for certain types of learning, more sensorimotor activity in the brain is related to better learning outcomes. So for instance, there's a study about learning physics, and when you have an embodied learning experience where you use your body, we see a mechanistic path for greater sensorimotor activity leading to better learning outcomes. Another reason that we might look at neural responses to support our evaluation of learning is that neural measures can also reveal embodied processing on a pretty short time scale. So for instance, using EEG, you might be able to see changes that occur just from a brief amount of experience with a particular training or with a particular action. So those might be missed if we were to use only behavioral measures. So to break it down, if we want to ask whether someone is engaging in embodied learning, in interacting with a social interaction with a virtual human, we could look at the sort of traditional aspects of learning. Did they retain the information? Do they know more than they did at the beginning? Can they remember what they learned? But we can also look at the more mechanistic embodied aspects by using a number of different neuroscience methods. So just for instance, we can look at sensorimotor activity using fMRI or EEG, or we can use TMS to disrupt the system and see how that impacts learning. I'll show you what that looks like for this particular project. So we built the 3D learning environment, and what we want to ask is how that experience being in the virtual reality exchange with the avatar, how does that change our later our later processing of the content compared to other types of learning experiences? So this is work that should have happened during the pandemic, but could not. So I'll use the future tense because we'll be back at it as soon as we can. We'll be comparing the SAIL virtual reality group to a separate group of participants who see similar content, but not in immersive virtual reality, and a third control of a VR group who's learning a different language. And we propose that after training, we'll measure the EEG mu rhythm in response to the learned and unlearned ASL signs, a sort of paradigm that we've already shown what the EEG mu rhythm is doing when people do and do not understand ASL signs, if they're familiar with the content or not. But we will use that as a measure to look at the engagement of the sensorimotor cortex. So this is one particular way that we can look at the mechanism that we are interested in. Specifically, we hypothesize that we'll see more sensorimotor engagement and better learning outcomes from the SAIL VR condition due to the more three-dimensional and immersive nature of that social interaction. And so this comes to our challenge, which is combining the explicit and implicit measures to assess learning in VR with this virtual human. And, we could use any number of other implicit measures. So we might be looking at things like physiology and, we could add on a whole number of other ways of measuring this, but based on the theoretical framework that we're working within, for us, it's important to look at this mechanism of potential embodied learning. But taking a step back from that particular example, as I was reading the paper that sort of started this webinar, I was just reflecting on the fact that all social experiences, whether with a humanoid robot, a virtual human, or a real human, are multi-layered and contain things that we're conscious of and things that are underneath our conscious level of perception. So it seems intuitive and necessary that measuring those experiences just has to involve multidimensional approaches. And no specific measurement is going to give us all the information we want, but by combining a few, particularly those which relate to the theoretical framework within which we're working, we can get closer to understanding the human social phenomena that we're looking at, whether that's human machine, human virtual human, or any number of other combinations. Okay, with that, I'll say thank you to the NSF for our funding and my colleagues and students, and also put a plug for we're now hiring a postdoc, so someone let me know if you're interested or if you have any ideas. And that's it for me. Thank you so much.